Is Vladimir Putin secretly building a powerful underwater arsenal for the next era of conflict? And is he doing it with European machinery and high-end technology helping him from the shadows? Is President Zelensky now facing a double shock, as Russia quietly expands its nuclear arsenal, even while the war in Ukraine grinds on and Western support stretches thinner by the month? At the same time, are missiles packed with European-made parts still slamming into Ukrainian cities, raising uncomfortable questions about how these components keep slipping through the cracks? Are Yasen-M nuclear submarines now being built to stalk NATO seas for decades to come, turning Russia's undersea fleet into a permanent shadow trailing Western warships and carriers? Has NATO just unlocked a new fear, as Europe not only prepares for the risk of a land invasion, but also starts to worry about Russian submarines shaping the next great showdown at sea? If Putin ever chooses to challenge NATO directly, will his first move come not across the land border, but through the oceans, with a deadly submarine fleet slipping under the alliance's defenses? As the Ukraine war steadily drains Western resources and attention, Moscow is already planning for decades of naval rivalry, laying the groundwork for a long undersea contest with NATO. On June 17, Russia quietly laid the keel of a new Yasen-M nuclear submarine in Severodvinsk, signaling that even in wartime it is still investing in next-generation undersea power. The new vessel, named Murmansk, became the 9th Project 885M boat in the series, raising the question of how many of these high-end hunters NATO is prepared to track at once. This keel laying at Sevmash in Severodvinsk is the first for this class since 2020, suggesting Russia is now ready to restart the production rhythm it lost in the early war years. Yasen-M, known to NATO as the Severodvinsk class, is Russia's most advanced attack submarine design, built to hunt in silence and challenge Western navies far from Russian shores. This class is engineered to hunt enemy warships, stalk other submarines and strike land targets, raising fears that it could hit ports, bases and cities without warning from beneath the waves. Its missile arsenal includes Kalibr, Oniks and even Zircon hypersonic weapons, forcing NATO planners to ask how they will defend carriers and coastal sites from such fast, long-range strikes. Interestingly, recent Yasen-M boats are reportedly being fitted specifically for Zircon hypersonic missiles, turning each submarine into a mobile platform for some of Russia's most advanced weapons. The original Severodvinsk was laid down in 1993 and only entered service in 2014, a 20-plus-year saga that showed just how badly Russia's shipbuilding industry struggled after the Soviet collapse. That 21-year build time exposed how far the post-Soviet naval industry had fallen, raising doubts back then about whether Moscow could ever field a modern submarine fleet at scale again. However, reports say the improved Kazan was laid down in 2009 and commissioned in May 2021, showing that Russia managed to cut timelines and push the design toward a more mature, repeatable build. Kazan's shorter build time hinted at new maturity in the Yasen-M design and better production practices at Sevmash, raising alarms that Russia could now produce these subs faster and more predictably. Novosibirsk reportedly joined service in 2021 and later shifted to the Pacific Fleet, suggesting Moscow wants these advanced subs patrolling not just Europe's waters but also the Asia-Pacific. Krasnoyarsk followed in 2023 and then redeployed to Kamchatka the next year, reinforcing Russia's undersea presence in the Pacific and signaling a long-term focus on that theater too. Arkhangelsk joined the Northern Fleet in 2024 after completing sea trials, adding another modern attack submarine to the high-stakes Arctic and North Atlantic routes NATO depends on. K-572 Perm rolled out from the Sevmash yard in March 2025, showing that new Yasen-M hulls are now leaving the sheds and heading toward frontline duty. Perm is the first Yasen-M reportedly designed from the start around Zircon missiles, raising the prospect of a dedicated hypersonic strike submarine roaming NATO's sea lanes. By 2026, Perm was said to be undergoing sea trials, inching closer to full combat readiness and forcing Western navies to factor it into their future patrol plans. Ulyanovsk remains under construction at Sevmash, another sign that the production line is still moving and more advanced attack subs are on the way. Voronezh and Vladivostok were both laid down in July 2020, indicating that Russia committed to multiple boats at once even before the full shock of the Ukraine war hit. These two submarines stem from a June 2019 contract, proof that Moscow's long submarine push was locked in well before today's open confrontation with the West. Their delivery dates are currently listed as 2027 and 2028, meaning NATO could be facing even more Yasen-M boats in the water before the decade is out. Interestingly, Murmansk will not enter service for years, even under generous timelines, which raises the question of why Russia is pushing ahead with a sub it knows will come online much later. Yet its keel-laying shows Russia is committing to long-term naval power, signaling that Moscow expects to challenge NATO at sea not just now but well into the 2030s and beyond. Moscow is clearly prioritizing nuclear submarines despite huge pressure and costs from the Ukraine war, suggesting it sees undersea forces as a non-negotiable pillar of its future strength. This program strongly suggests Russia is preparing for future contests with NATO at sea, from the Arctic to the Atlantic, and possibly the Pacific too. With 9 advanced attack submarines now in the pipeline or in service, Moscow is placing a decades-long undersea bet that could reshape how NATO thinks about maritime security. New analysis by the War Zone detailed how Russia's Skyfall nuclear cruise missile may operate, offering fresh insight into the secret of weapon. MIT researchers concluded the Burevestnik likely uses a direct-cycle nuclear propulsion system rather than a conventional engine design. The finding raised new questions about whether the missile releases radioactive material during flight and normal operation. As per the study, the weapon may be far more environmentally hazardous than previously understood by observers. Researchers Hekla and Kemp analyzed open-source data on size, speed and engine design, according to TWZ. They said the missile marks the first suspected sustained flight of a nuclear-powered aircraft-type system. Russia revealed the Burevestnik program in 2018 as one of President Putin's flagship superweapons projects. The project followed decades of failed US and Soviet experiments involving nuclear-powered aircraft concepts. Previous tests included US Project Pluto and Soviet-era airborne reactor experiments with similar ambitions. Several reported test incidents since 2017 were linked by experts to the missile program and its development. A 2019 explosion near Nanoxa killed Russian scientists and triggered radiation spikes in nearby areas. Missile length estimated at 31 feet, 9.5 meters, making it comparable to a small aircraft-sized weapon. Wingspan approximately 18 feet, 5.6 meters, according to estimates cited in the analysis. Estimated speed, Mach 0.75, indicating a subsonic flight profile focused on endurance rather than speed. Likely engine type, a direct-cycle nuclear turbojet system powered by an onboard reactor. Airflow passes directly through the reactor core, where it is heated before producing thrust. Result, propulsion generated by radioactive superheated exhaust expelled from the rear of the missile. Air is drawn into the missile and passed directly through the nuclear reactor core for heating. A compressor forces air through narrow channels surrounding the reactor's fuel rods. Fission heat superheats the air before it is expanded to create powerful rearward thrust. The superheated airflow exits through a nozzle to generate continuous propulsion during flight. No sealed coolant loop is used, meaning radioactive materials are not fully contained within the system. This design makes the system's engine compact, but also potentially highly contaminating, according to the report. Direct cycle system. Air passes through the reactor core and exits as potentially radioactive exhaust. Indirect cycle system. A sealed coolant loop keeps radiation contained inside the reactor structure. The direct system enables a smaller missile design, but may release fission particles into the atmosphere. Researchers warned the exhaust may contain argon, krypton, and carbon isotopes generated by reactor activity. MIT researchers said the system would likely produce a radioactive trail throughout sustained flight operations. They said long-duration cruising would increase radiation leakage risks and accelerate reactor wear. Experts warned corrosion inside the reactor core could generate additional contamination over time. Former arms control officials said the design combines low speed with relatively high trackability. They argued it offers range advantages but weak operational stealth and limited overall military value. An investigation has exposed how the EU machinery kept feeding Russian missile makers. EU industrial exports continued flowing into Russia despite sanctions. Customs records reviewed by Kiev Independent and Irpi Media revealed a sanctions bypass network, documented trade routes evading restrictions. Records showed EU-made industrial machinery reached Russian defense-linked plants via Turkey, used as a third-country transit hub. Those plants produced specialized metal alloys used in missiles, fighter jets and weapon systems, key inputs for military production. Investigators said the case showed Russia's war industry still depended on Western technology, despite broad export sanctions. The shipments were traced to facilities controlled by a family linked to Russian giant Rostec, a state-powered defense group.